Hey guys, it's Mrs. Bryant. Welcome to another flip video. We are going to be talking about solving systems of linear equations by substitution. This is going to be a two-part video lesson. Today's video is part 1 and tomorrow night's video will be part 2. Before we start, I need you to make sure that you have the notes that I gave you in class on Friday and make sure you are following along as I go through the lesson. So let's go ahead and get started. Before we start today's lesson, let's get something figured out. What is 3 plus 5? We all know the answer to that is 8. What is 2 plus 6? Well, we all know the answer to that is 8. So what does 3 plus 5 equals 2 plus 6 equal? Or are they equivalent? Of course, yes, they are equivalent. We proved that because they both equal 8. So why is this? It's because if 3 plus 5 equals 8 and 2 plus 6 equals 8, then 3 plus 5 must be equal to 2 plus 6. They are equivalent, equal, or the same. So what does this all mean with algebra? And that's what we're going to do today. You know that we have been solving systems of linear equations using tables and graphs. Today we are going to be doing it by setting those expressions equivalent to each other. So let's talk about this problem. Christina is looking for a babysitter. Daniela charges $3 per hour to babysit kids in Christina's neighborhood, and she requires no registration fee. Victoria, on the other hand, charges $2 per hour to babysit kids, but she also charges a one-time registration fee of $6 per family. It says write an equation for each babysitter where H, notice it's telling you what your variables are, represents the number of hours of babysitting, and C represents the total cost. So for Daniela, C would be 3H. She charges $3 per hour. For Victoria, C would equal 2H, $2 per hour, plus the $6 registration fee. And we can check our answers to make sure that we are right, and we are. Christina is looking for a babysitter. Obviously. Now it says graph both equations on the coordinate plane below. Use the green marker for Daniela's equation and a red marker for Victoria's. We're going to do the math in our head. These are simple equations, so we shouldn't need to write it down, but if you needed to, you could make a table. So, if I put a 1 for H, 3 times 1 would be 3, so you could draw your first dot there. If I put a 0 to see where it starts, our line would start at the origin. You will notice that this is a proportional relationship. 2 hours would be 6. And I'm going to skip 3 and go to 4. That would be 12. 6 would be 18. And so on. So now that I have my lines, there's my graph. So let's do Victoria's. Victoria, if I put a 0 here, 2 times 0 is 0, plus 6 would mean I'm starting at 6. So it would cost $6 whether she babysat or not. If I did 2, 2 times 2 is 4, plus 6 is 10. If I do 4, 2 times 4 is 8, plus 6 is 14. If I do 6, 2 times 6 is 12, plus 6 is 18. And so on. So there's our line for Victoria. So let's answer some questions. What do we notice? Well, we notice that 1 is proportional, 1's not. We also notice that our intersection or our solution would be right there because that's where both lines cross. All right. So for what number of hours is Daniela the cheaper babysitter? If you look at total cost, she's cheaper all the way up until this point. So any hours less than what? If you said or thought 6, you would be correct. And it says what number of hours is Victoria cheaper? Well, look at the total cost. At this point, she's cheaper after the intersection. So any numbers, any hours greater than 6. And then it says for what number of hours is the cost of each babysitter the same? And we know that as our intersection, so our answer would be 6 hours. So now it says to put it in your calculator, but I went ahead and gave you your tables. It says, what do you notice? Well, it tells you how many hours and how much is going to be each, how much is going to cost each. So it wants to know, for what number of hours is Daniela the cheaper babysitter? So you're looking at the table for the numbers that are less than Victoria's. If this is Daniela and this is Victoria, 0, 3, 6, 9, 12, 15. They're all cheaper than Victoria. So again, we're going to say any hours less than 6. And for what number of hours is Victoria cheaper? Well, it's all right here. So 7, anything greater than 6. And what numbers is it the same? And that's our intersection right here. 6 hours. So what have you noticed? We had the same solution with the graph, and we've had the same solution with the table. So let's explore this question further. For what number of hours is the cost of each babysitter the same? If we want to know the value of H hours, we'll make both equations have the same value for C total cost. Couldn't we set the two expressions equal to each other and solve algebraically to find? And the answer is yes, we can. So let's do that. We have set Daniela equal to Victoria, and now we need to solve for H. This is something we've been doing for the last 6 weeks, so we should not have a problem with this. We know we need all variables on one side and we need all constants on the other. So in order to do that, I need to move this 2 over. So minus 2H minus 2H. I'm left with H equals 6. So H equals 6. If each babysitter works 6 hours, the total cost C will be the same. So what is the total cost when the number of hours each babysitter works is the same? We know the value of H hours that will make the cost the same for both babysitters is 6. So let's substitute, this is where the name comes from, the value of 6 into one of the original equations. And when I do that, I choose the one that looks less messy. So I'm going to use C equals 3H. So C equals 3 times, and what we got 6 for H, so I'm going to plug in a 6 there. So C equals 18. The total cost for each babysitter at 6 hours would be $18. And that's what that says right there. So no matter which method we used, the solution was the same. Graph. When we did the graph, the intersection of the graph of each equation was 618. For the tables, when the value of H was 6, both values of C were 18. Now algebraically, when H equals 6, C equals 18. So at 6 hours, both babysitters cost $18. And now we can check that solution. You know, we've always said you need to go back and check your answer. So 18 equals, or C equals 3H, 18 equals 3 times 6, and that's true. And then we know it's 18, and 2 times 6 plus 6 equals 18. So both statements are true, so the solution 618 satisfies both equations. Our solution is correct. So let's solve this system by setting both expressions equal to each other. So x plus 2 equals 3x plus 8. You know you need variables on one side and constants on the other. So I'm going to move this x over. That way it stays positive. I'm left with 2 equals 2x plus 8. Bring this 8 over, and I'm left with negative 6 equals 2x. Divide by 2, x equals negative 3. But that's only part of our solution. I know that I need to plug in this to get my y. So I'm going to choose this one because it's less messy. Y equals negative 3 plus 2. And so y equals negative 1. So our solution would be negative 3 comma negative 1. And you can check your answers, and you'll notice that's exactly what we have. Another example. Solve by substitution, so negative 3x minus 6 equals x minus 4. So I'm going to minus x here, minus x here. Those cancel. I have negative 4x minus 6 equals negative 4. So plus 6 plus 6. Negative 4x equals positive 2. Divide by negative 4, divide by negative 4. X is equal to negative 1/2. Or you can have it in a decimal as negative 0.5. I'm going to plug this into one of my original equations. Y equals negative 1/2 minus 4. When you do the math, your answer is y equals negative 4.5. So our solution is negative 1/2 comma negative 4.5. And you can check that. Okay, so before we solve this system, what do you notice about the equations? Well, you notice that your x or your coefficients are the same. And so let's see what happens with that. 5x minus 8 equals 5x plus 3. So minus 5x minus 5x, they cancel, they cancel. You're left with negative 8 equals 3. Is that a true statement? No, it's not true. So are we going to have a solution? If it's a not true statement, we have no solutions. And we can check that. This is a false statement. Negative 8 does not equal 3. There is no value of x that can make both sides of the equation equal. So in that case, there is no solution. Alright, we need to solve for y first. So we have y equals 3x plus 4. Now what do you notice about these two equations? They're the same. So in my mind, I know that if I have the same coefficient and the same y-intercept, or same slope and same y-intercept, I have infinite solutions. But I want to practice, so 3x plus 4 equals 3x plus 4 minus 3x minus 3x. I'm left with 4 equals 4. So we know that's infinite solutions. And we can read this. So when you solve for y in the first equation, you get y equals 3x plus 4. This is the same as the second equation. We can set both the equations equal to each other and solve for x. This is a true statement. 4 does equal 4. This means that any value of x will make both sides of the equation equal. There are infinitely many solutions. Now, your job is to do the next two problems, the one about Joe and the one about Carlos, and have them done before you come to class tomorrow. And we will go over them before we do the actual work in class. If you have any questions, please make sure you leave them below in the comments, and I will get them to you, or get the answers to you as soon as possible. Thank you, and I'll see you in class tomorrow.